Okay, so first off, um, okay, so let's recap. So I'm given this point 1 and 2. So let me plot this point on the grid first. 1 on the x, 2 on the y. So it's this point right here. And from that point, if I'm given the slope, what do I do? A slope of 4 over 5. What's my rise? What's my run? Alvin? Sure. Okay, sorry, Alvin. What did you say? Yeah, so the rise is 4 and the run is 5. Yeah. Yeah, so guys, for this chapter, you wanna have rulers. So rise over run. So that means I'm gonna go up the elevator for 1, 2, 3, 4, and then it's the fifth door on the right. 1, 2, 3, 4, 5. So once I have 2 points, I can graph my line. Something like this. Okay. So this is what we did yesterday. But, so this is point A, but this is not my point B, because point B, I gave you half of the coordinate. The half of the coordinate is when it's at -4. So instead of this point, I'm looking for the point that's over here. So remember, your slope, you can do up 4, 1, 2, 3, 4, and 5 over to the right. At the same time, you can do down 4, 1, 2, 3, 4, and then 5 to the left, as long as you know the direction of the line. So in this case, what is the coordinate of B? Jasmine, can you read what that coordinate is? That is negative 5, 4. Yeah. And then negative. Perfect. Okay. So therefore, K is -2. Okay. So the purpose of this is, 1, recapping how to graph the second point given the slope, and 2, remember your slope, you can go either way. What I taught you guys yesterday was if it's positive, we go up and to the right. It's the same thing if you go down and to the left, because it's kind of like 2 negatives make a positive. So as long as you know the direction. Okay. Same idea with these ones, so I'm just gonna skip it. I want to do some application questions with you guys. So Sarah is on the soccer team and runs every morning before school. One day she ran 5 kilometers in 20 minutes. Calculate her rate of change. Okay, so remember, rate of change is just like your slope. Okay, is the rise over run, or the difference in y over the difference in x. So remember, difference in y over difference in x. Kilometer, minutes. Which one is your y? Kilometers, right? So 5 kilometer, 20 minutes. So when you divide it, you get, what do you get? Yep, a quarter. Kilometers per minute. Perfect. Yes. Okay. So when you divide it, yes, it's 1/4, or if you, because this word problem, it makes sense to use decimal. So 0.25 kilometer per minute. Okay. So your rate of change has 2 units, just like when you're doing a unit rate. It's the same idea. Okay. So rate of change includes 2 units. So if we were to graph it, that means on the bottom right here, your x, 99% of the time, is going to be time. Okay? And then your y right here is going to be your distance. What is this number right here again? Right here in the corner. 0, right. So, oh, by the way, you will get back the group assignment. And some people forgot that this corner is 0, 0. Right? You cannot just start off with like 50 right at the corner. And then it says every 20 minutes. So I could do, for example, 10 minute, 20 minute, 30, 40, 50, 60, 70, 80, and so forth. And then here for distance, I can do 5 kilometer, 10 kilometer, 15, 20, 25. Okay. So when I plot it, I know that her rate of change is 5 kilometer for every 20 minutes. So 5 kilometer every 20 minutes. So after 40 minutes, it's at 10. After 60 minutes, it's at 15. After 80 minutes, she has ran 20 kilometers. Right? And then connect the dots. Oops. Okay, and there's her graph. Explain the meaning of the rate of change and how to relate it to the graph. Okay. So on EQAO, they love to ask you what is the meaning of the rate of change. Okay. So what is this graph showing? When you have a distance time graph, yes.
The distance, do I have to say in general or just according to this?
Up to you. Even in general.
Distance Sarah runs in minutes.
Okay, yep. So as we said, this is a distance versus time graph. But when you think of distance and time, what comes to mind when you're comparing distance and time?
Speed.
Speed, exactly. So in this case, your rate of change is speed. Okay. So that's the purpose of these application questions is you have to know what your slope represents. So in this case, it represents speed. Okay. What about this one? Okay, I give you the graph. And I have the point 0 and 65 and 505 right here. So to calculate the slope, remember again, it's the difference in y over the difference in x. So what's the difference in y right here? Oh, you could, let's use the formula. We haven't used the formula. Let's do y2 minus y1 over x2 minus x1. We could either use a formula or we could just count the boxes because you're given a graph. So those of you who are wondering what is x2, what is y2, so I could call this x1, y1. I can call this point x2, y2. So now if I were to sub in the value, y2 is 5, y1 is 65, x2 is 500, and then x1 is 0. When I substitute it in, I get negative 60 over 500. I can reduce that to negative 6 over 50, so negative 3 over 25. Okay. Since this is a word problem, I'll do decimal. So negative 0.12. What would my unit be here?
Liters per kilometer.
Liters per kilometer. How did you do that so quickly? Because Max looked at the axis. So that tells me it's liter per kilometer. And then, yeah.
Like, we just randomly pick two spots and X1,
So they gave you these two coordinates, and so that's why I was able to use the formula. It doesn't matter which one you call x1, x2, or y1, y2. As long as this is your first point, then it's x1, y1. This is your second point, then call it x2, y2. But never write it as x1, y2. Okay. So what is this graph showing us? So again, we need to know in this case, sorry? Fuel consumption. Wow, you're really good at this. So in this case, my rate of change here is fuel consumption. Consumption. S-I-O-N? Consumption. T or S? T. T? Like that? Looks wrong.
Isn't it S?
Isn't it S? Consumption. 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 How do you spell it?
I think that's right.
It is? Let me see. Time to ask Google. Oops. Yep, it is.
Does it change?
Yeah.
I believe like hard they express fuel consumption as liters per 100 kilometers.
Oh, good.
That was
Yeah, you could. So this is like a unit rate. Remember, rate of change is basically a unit rate. So if I were to express it as per 100 kilometer, then just do this times it by 100. So that means this car goes at 12 liters per 100 kilometers, which is pretty high, actually. Okay, so these application problems right here, you have to, excuse me, it's just figuring out what the rate of change represents. Okay, so I do want to start on this. So page 10. Page 10. Yeah. Okay, so graphing linear equations. So if you are given the equation y equals mx plus b, what is your m? What is your b? So remember it's y equals mx plus b. So if you match it up, m is, right, 3 over 4. No x, no x, no x, okay? Just like what we've been working on, m is always just the number. And what is b?
1.
1, yeah. So the graph right here, so we always graph the b first. Graph this. Graph this point first. What does b represent again? What does b represent in a graph, Sophia? Y-intercept, right? So on the graph, I can plot a point right here at 1. That's my y-intercept. And then from this point, I'm going to do my slope. Not from 0, 0, but from the point, just like what we've been doing. I'm going to go up 3, 1, 2, 3, and over 4. 1, 2, 3, 4. Okay, and that's my line. So just like that, without having to do a table of value, I just graphed a line in 30 seconds using y equals mx plus b4. Yeah, we'll do another one. All right. So, Yan, can you help me with this one? Y equals mx plus b. So what's my m? Perfect. And my b? 6. Yeah, that's it. All right. Which do I graph first? B, right? So my B is 6. I'm going to put a point on my y-intercept. 6 is my y-intercept. And then from this point, I'm going to do my slope of -2/3. Right? So remember the elevator trick yesterday? We talked about it. So Hannah, what do I do from this point? Down 2. Yep.
Oh, yeah.
And then to the right on 3.
Perfect. Okay. Now, is this so much faster than doing a table of value? Yes. Okay, and that's my line B. Okay. Let's do one more. Y equals 2x minus 7. So Daniel, y equal mx plus b. What is m? If you just match it up. So y equal mx plus b, like this. So m is what number? 2. Yeah, 2. And what is b? -7. Good job. Alright. So on my y-axis, I'm gonna plot -7, which is right here. Okay. Okay, Max, what do I do? My slope is 2. So what do I do? Rise over run. For all slope, I need a rise and a run. Betsy, what do you think? Up 2 and then
1 right.
1 to the right. That's right. You have to get out of the elevator. 2 is the same as 2/1. Right? So if you don't see a run, your run is 1. That rhymes. Okay, and then that's C right there. Okay. Yep.
You have to draw the lines down.
It shouldn't be this short. So you don't have to do it so long. I just did it so long because I know I'm gonna get other lines. So that's why I made it long. Okay. And when you do your homework, you could do all the graphs, all the lines on one graph. Just make sure you label it. So I don't need you guys to make like 10 different graph, 10 different scale. You can graph all of them together, but just make sure I can see which is which. All right, so I'll stop here. So I'm just gonna get you guys to do page 7. So just page. Okay, let's do page 7 and page 10. Page 7 and page 10. All right. I skipped it quite a bit for you guys. Okay. So page 7 and 10. That's it.
Not here.